In this video, we're going to discuss area between the loops of a Limacon. So we are given r equals 1 minus 2 sine theta. I want to find the area in between the loops. So it's important to understand how the graph is being traced. When I trace the outer loop, the in between inner loop is also traced in that. So when I find the area of the outer loop, the inner loop is also included in there. So I'll have to find the area of the inner loop and subtract it from the area of the outer loop. So let's first find the area of the inner loop. Where does inner loop start and end? Where does inner loop start and end? Inner loop start and end whenever I'm back on the pole, whenever r is equal to 0. So let's go ahead and plug r is equal to 0. 1 minus 2 sine theta is equal to 0, which gives me sine theta is half. Sine theta is positive half in the first quadrant, and it's positive half in the second quadrant. So reference angle is pi over 6, and in the second quadrant, it would be at 5 pi over 6. So area of inner loop is going to equal pi over 6 to 5 pi over 6, 1/2 r squared, which is going to be 1 minus 2 sine theta squared d theta. Let's see, using an integral calculator, what does that turn out to be? So I got 2.2203. 2.2203. Don't one thing, when you put it into the calculator, we will be using x because the calculator doesn't have a button for theta, so it would be remember to put the parentheses twice, because when you put in x, it's going to put parentheses around. So put another parentheses, then put the square there. And sometimes calculator takes a few seconds to calculate, and that's okay. Don't be impatient, just wait. It's working something out. Right, now we're going to think about, where does the outer loop start and end? Where does the outer loop start and end? So let's think about it. When r is equal to, it's very helpful to think about graph of r is equal to 1 minus 2 sine theta. So I'm going to go ahead and graph this function. I'm going to use Desmos to graph it because I can get the key points on the x's. It's a shifted graph, so getting the key points on the x-axis is not so easy, but on the shifted axis, I can have them. So where does the outer loop end and start? So if theta is equal to 0, where am I? When theta is equal to 0, I'm going to be over here. When theta is 0, I'm here. So I can do two things. I can either go make the inner loop going from pi over 6 to 5 pi over 6, and then pi over 6 to 5 pi over 6, and then keep going further than 5 pi over 6 to complete my loop. Or instead of starting at theta is equal to 0, I can go way back and instead of, before I go to pi over 6, I can go way back to negative 7 pi over 6, which is easy to see from the graph of this function. So if you look carefully here, that's the graph we're looking at. So these are the key points I'm interested in finding out. Here's my bigger loop and then my smaller loop. So I can either go back, instead of starting at 0, I can go all the way back, start at negative 7 pi over 6, and complete my outer loop at 7 pi over 6, start the inner loop at start at negative 7 pi over 6, complete my outer loop at pi over 6, and then complete my inner loop at 5 pi over 6. Or I can go ahead and start the inner loop at pi over 6, complete it at 5 pi over 6, and keep going further until 13 pi over 6. So that's your choice. You can set up the integral in two different ways. Bigger loop, smaller loop, and then again bigger loop. Okay, so this was negative 7 pi over 6, this was pi over 6, and this was 5 pi over 6, and this point was 13 pi over 6. This point was 13 pi over 6. Okay, so that's a negative here. Now, we want to find out, okay, so when we set up the integral for the outer area, for the outer loop, we can either go negative 7 pi over 6 to positive pi over 6, and 1/2 1 minus 2 sine theta squared d theta. Or we can also set up the integral. We can say, well, my inner loop starts here, ends here. Now the outer loop is going to begin from 5 pi over 6 to 13 pi over 6. So 5 pi over 6 to 13 pi over 6, that's where my outer loop is 1/2 1 minus 2 sine theta squared d theta. So I can use either one of these integrals, just understanding how the curve is being traced. Because if you start at 0 and you go all the way up to pi over 6, you're not completing your loop. Start at 0 and you go all the way up to pi over 6, you are not completing your loop. You have a part of the loop that's left uncovered. So I have to go backwards to be able to complete that. Or once you're back at 5 pi over 6, you will have to go further than 5 pi over 6 to be able to complete the loop. All right, so now I'm going to go ahead and find this integral using the calculator. And then I was interested in area in between the loops, So use the calculator. Bounds are fractional bounds. Turns out to be, I have 8.88. 8.88 is the area of the outer loop. Again, you can consider your outer loop going from here to here, and then your inner loop from here to here. Or you can consider your inner loop from here to here and outer loop from here to here. Both ways, it's fine. Because your curve is going over and over. It's tracing over and over the same region. And there's many more for other values that you can use if you continue the curve on the left and right hand side. So area of the outer, area in between will be area of the outer loop minus area of the inner loop. 8.88 minus 2.22. 2.22. What does that turn out to be? 8.88 minus 2.22 is going to be 6.66. Okay, so that's all about area in between the loops for this Limacon. R equals 1 minus 2 sine theta. It's also very helpful to go ahead and make a graph of thetas and r's and see what is happening to your curve.